Today we are discussing the compiler technology. The book we follow, this Aho Schettulman book. I chosen this the earlier edition, the front cover. I like it very much, but this is edition is freely available. Compiler is nothing but a software, a very advanced software. We can call it uh, all kinds of features like dynamic programming, various kinds of uh, very advanced software techniques. These are used in the compiler technology. This is showcase of computer science, and this is the source program, maybe C, C++, Java, and the compiler is basically nowadays two type. One is compiler is like C, C++ from here to actual the target code, and another is interpreter like Java and Python, but the basic technology is the same. May go to the next slide. This is the compiler versus interpreter. This line of action is the compiler, the like C, C++ here. Our actual target code is which is run on a particular machine, and the interpreter is nothing but a line by line code interpretation, and it is response is faster like Java and Python. The virtual machine is either Python or Java. This is nowadays modern code which runs on many machines. This is a typical Java interpreter. This is a scanner or lexicon analysis, the same thing. I am using the pictures for various textbooks, so students must follow the format, the textbooks, like somewhere there is lexical analysis, lexer or scanner. The parsing we will discuss in the next sections. Parsing can be done top-down parsing or bottom-up parsing, and this is basically a Java virtual machines, Java interpreter. This is a diagram of the compilation process. The first stage, it is the front end with here the lexical analysis, syntax analysis, the semantics analysis. Most important is the syntax analysis. Here the crucial amount of our course will be there with the top down and bottom up. We'll later see the bottom up is the best one, and this is the lexical analysis. Today's our topic is lexical analysis. This is the front end. This is called analysis portion, and then the synthesis portion. It can be from one to intermediate code, and from intermediate code it can be any target processor. We can generate the target program. This is a design diagram of the compilation process from another book. The same thing is the front end. Here the concept is the front end, the same portion, the scanner or lexical analysis, parser, semantic analysis, machine independent, and the machine specific target code generation. This is the same thing here. We can see it here. The source code is here. Here the while is a keyword. This is one token, the keyword, and this is the identifier, and this will go like here. Basically, number of tokens is while is itself a token, is a keyword, and these are the number of tokens are coming. And when the identifier is this, and this is also keyword greater than. This is keyword. This is keyword. This is the thing. The lexical analysis, syntax analysis, and the semantic analysis. This is that I book the Aho Apkar book. This is the same scenario, and here the important information comes the symbol table. This is a very important data structure which will created in the lexical analysis phase, and it is also updated by the syntax analysis, and information will back and forth, and semantic analysis, and in the whole life cycle of the compilation this will be used. So this is very important data structure. It is generally implemented, can be in various ways, but modern techniques is the hash table concept. Will come this thing. This is filling up will be with the all the identifiers. Remember the keywords and the constants will not be here. Here basically the identifier, here in the first line, the position is identifier, initial is identifier, and rate is identifier. See here 60 doesn't come. And here the identifier, what type of identifier? It is integer, floating point number and all, and what is the scope? All they are implemented in a table. It may not be a single table. It depends on multiple tables. We'll discuss very details in symbol tables in our next lectures. Here the symbol tables are there, lexical analysis. The first thing, lexical analysis is nothing but a finite state machine simulated to identify the, here it is identify the identifiers and integers. We can identify because all identifiers must be start with like letter, and then it can be digit or underscore. So this will be treated as a identifier, and digit will be, it must start with 1 to 9 and only digit. So like with finite state machine, we can detect whether it's a digit or identifier. It is the final state. The final state, this shown by concentric circles, we can identify. This is basically nothing but a FSM machine. We can identify this lexical analysis, that the core heart of this is multiple FSM machines are running. It is the distinguished reserved dots and identifiers, whether it is reserved dot or like here, if you say in Java, the new is a keyword. Here the Java is a new is a keyword, like new is a keyword. It is detected. Null is a keyword, so that is a, it is automatically got it in the particular table. And int is a keyword, so it will be detect the keyword. Same thing, the identifier whether digit or not. Here it is identify the recognizing the equal to or double equal to or not or and. This is the lexical analysis step, whether it's a semicolon and whether it's a, if one equal to got, if there's another equal to, that is a another keyword. If it is single equal to one, dot is another keyword, start is another keyword, like this. Is a state terminal for recognizing to semicolon as this. This detects the white space, dealing with the white space. Very important because we any programs like Java, you have to detect, or C, you have to detect the various kinds of white spaces. This is like C++ and Java. There's a double hash is a to detect double hash for comments as a white space. This is the FSM machine to detect this. There's a multiple FSM machine to detect identifiers, numbers, real and white space, like this. These are the lexical tokens, various lexical tokens, because if it is like here, like foo, N4, this is the, or because starts with a, this is identifiers. So it goes to the symbol table. This will not go to symbol table. These are numbers. These are the numbers. This will not go. If is a keyword, comma, it will be detected. It will be detected. Left parenthesis, right parenthesis. It will not go to the symbol table. Like here in the C language, like this is. This will be taken out. This will be taken out. This will be taken out. This will not go to this. These are all not go. So these are the macros. That will be taken out from the program. So what is the tokens? The another name is tokens are lexemes and versus terminals. Here we see that this particular code here. Yeah, this is, we see it here. These are identifiers, identifier 1, this is identifier 2, initial, identifier 2, this is identifier 3, this is not good to the identifier, this is lexical analysis, and after lexical analysis, these positions name will not be there, it will be identified like ID, comma 1, and this will be linked with this, this table, that is called symbol table, and these are the tokens or lexemes. So with this we end it here. We will clarify with the board syntax analysis, semantic analysis and various stages of how the symbol tables is organized. We will discuss in our next sessions. Thank you for being.